All right, we're going to continue looking at linear functions, but we're going to look at some situations where maybe our data isn't exactly linear, but we can still model it with a linear function because it's close to linear. All right, so we have the situation where we have a student walking and we're recording the time. We'll let that time be sort of our x value. We're recording how far away they are at that point in time. So we'll let the distance be our y value here. We're going to treat this almost just like our previous problems, where we're going to look at our difference in x here. Okay. You notice each time we're still going up by 1 second each time. Well, now let's look at our differences in y's. So if we subtract 0.85 minus 0.25, we get 0.6. If we do 1.55 minus 0.85, we get 0.7. 2.2 minus 1.55 is 0.65. 2.75 minus 2.2 is 0.55. Okay? Now, while you'll notice these aren't exactly the same, but these changes in y are very close to the same. So, we can still use this to make a linear function. We're going to do this to find our slope. We're going to take these changes, 0.6, 0.7, 0.65, and 0.55. We're going to add them together and divide by how many we have. So we're finding the average of those. When we punch that in the calculator, we find that the average change is 0.625. So we're going to use that as our slope. Now our b value, again, remember where x equals 0. Well, when x equals 0, our y value is 0.25. Okay? So if we write our equation here, our equation therefore is going to be y equals m, which is 0.625, times x, plus 0.25, which is our b value. Now, it is asking us a second question, and how far would they be in 10 seconds? Well, to figure that out, we simply just have to plug in 10 for our x value. Okay? And by doing that, we find that they would be 6.5 meters away. All right, so let's look at a second example. And we're going to write a linear function for this set of data that isn't exactly linear. All right, so engineers are conducting an experiment in accident reconstruction, and we'll see how long it takes a vehicle to stop. Okay, so this is the speed a vehicle is going. We'll let that be our y, and we'll let the number of seconds be our x. Well, here again, you'll see there's a difference of 1 each time in our x value. Okay. Then let's look at our difference in our y values. Well, here it went down by 3. Here it went down by 4. Here it went down by 2. And here it went down by 3. Okay. So using the same process we used above, we're going to find our slope by simply taking all of these, adding them together, so -3 plus -4 plus -2 plus -3. We're going to divide by how many we have. Well, we have 4 of those values, and that gives us a value of -3. Okay? Now, to get our b value, well, we're going to start at our value of 65 here. And I want to take a step backwards, okay? Well, if I'm going down each time, I'm going to add. And I'm going to add something equal to my slope here, which is 3. Add 3, and I get a b value of 68. So my new function is going to be y equals negative 3x plus 68.